So in case you weren't here the day we did this worksheet, or you just need a little refresher, I'm gonna do this front part with you and show you how to do the back. So this is trigonometry. We're gonna use right triangles, and then we're going to learn how to do it. We have three functions that we're gonna work with. We're gonna work with sine, cosine, and tangent. Most of the time you're going to see it written as sine like this. If you want to say sin, it's sine. And it is the opposite over the hypotenuse. Opposite over the hypotenuse. Then cosine you're going to see written with COS, and it is the adjacent over the hypotenuse. And then tangent you're going to see written TAN, and it is the opposite over the adjacent. We're going to do these top three right here first. And if I am looking at angle A in this triangle, and actually you can put your finger on that angle, if I'm looking at this triangle, automatically I know the hypotenuse is this side. It is the side not touching the right angle. And so the hypotenuse can only be used for the hypotenuse. It can't be used for an opposite side or an adjacent side. So I'm trying to find the sine of A, which I know is the opposite over the hypotenuse. If I'm looking at this triangle and I am looking at the angle A, the side opposite angle A is the side not touching angle A. So that would be this side. And adjacent is the side touching A. Well, the hypotenuse is also touching it, but remember, the hypotenuse can only be used as the hypotenuse. So the other side, and it is a leg, will be used as my adjacent for angle A. It will change when we're looking at angle B. So if I'm looking at this triangle, looking at angle A, I want the sine of A. I'm going to put the opposite side over the hypotenuse. So my opposite side is that lowercase a over the hypotenuse, which is lowercase c. I'm looking at cosine of A. That is the adjacent over the hypotenuse. So my adjacent side would be my lowercase b over the hypotenuse, which is lowercase c. And the tangent of A is opposite over adjacent. Well, the opposite of angle A is lowercase a over my adjacent, which is lowercase b. Now I'm going to erase this. Remember, my hypotenuse will always be in that same spot of this triangle, so I don't have to erase a hypotenuse. But if I'm looking at these three, I'm now looking at angle B. So my opposite of angle B would be over here. That leg doesn't touch. And my adjacent would be the leg that does touch. So the sine of B is opposite over hypotenuse. Lowercase b over c. The cosine of B would be adjacent, lowercase a, over c. And the tangent is the opposite over the adjacent. Now this seems like a lot to memorize, but we've made up a word to help us memorize what is what, and it's called SOHCAHTOA. SOHCAHTOA. So the sine is the opposite over the hypotenuse. You can even put O over H, it doesn't matter. Cosine is adjacent over hypotenuse, or A over H. And the tangent is the opposite over the adjacent, which is O over A. So let's look at this triangle here. We have all three sides to that triangle. We're going to look at angle A. Sometimes it helps you if you put your finger on that angle. We're going to look first and see what is our hypotenuse. Well, here is the right angle. The side that doesn't touch that right angle is right here. This is going to be our hypotenuse. So the side that doesn't touch angle A, or the leg that doesn't touch angle A, is 5. And the leg, and over hypotenuse, I'm sorry, sine is opposite over hypotenuse, which is 13. Cosine of A would be adjacent over hypotenuse, so that would be 12. 12 is the leg that touches A over your hypotenuse. And tangent is the opposite over the adjacent. So now let's look at angle C. So hypotenuse still stays hypotenuse, it's still 13, but the opposite of C is 12, and the adjacent, the leg that touches C, is 5. The cosine is adjacent over hypotenuse. I'm sorry, I said this wrong. Opposite over hypotenuse, which is 13. Now, cosine is adjacent over hypotenuse, which would be 5 over 13. And tangent is the opposite over the adjacent. If you look at my tangents, if you're in the same triangle, same right triangle, these are only right triangles, and you're looking at the two acute angles. Those are the two acute angles. Look at my tangent. My tangent of one is the reciprocal of the tangent of the other. 5 over 12 and 12 over 5 are reciprocals of each other. If you look at your sine and cosines, sine of A is the same thing as cosine of C. And cosine of A is the same thing as sine of C. So if you are positive that you got these three correct, then you can just switch them up on the second one. If you're not positive and you need more practice, then do what we just did. On number 2, we're missing this side. This would be our hypotenuse, by the way, but we're missing it. If we have two sides of a right triangle, we can use the Pythagorean theorem. Okay, so A squared and B squared are my two legs, the two that make the right angle. So 9 and 12. It doesn't matter what order I put those in as long as they're in the A and B spot. And C would be, I don't know what that is. That's what we're trying to find. So 9 squared is 81. 12 squared is 144. C squared. If I add these together, I get 225 equals C squared. And I'm looking for C, not C squared. So I have to take the square root of both. So those cancel out. Square root of 225 is 15. So now I just got to look at W. My opposite is 12. Hypotenuse is 15. I can reduce that. 3 can go into 12 4 times and 15 5 times. Then cosine of W is adjacent over hypotenuse. So 3 can go into 9 3 times, 15 5 times. And tangent would be 12 over 9. So that would be 4 over 3. Now, if you remember the number 1 above us, we can just flip this. Or we can look at X and go, oh, that's 9 over 12, and then reduce it. And then the sine of W is the cosine of X. We don't flip it. We don't use a reciprocal. And the cosine of W is the sine of X. On number 3, we also have to find this. This is not the hypotenuse. 34 is my hypotenuse. So this is either A or B. It doesn't matter. It will still work out to be the same thing. And 16 squared is 256 plus B squared equals 34 squared, which is, let me make sure I'm telling you the right answer, 1,156. We'll have to get B squared by itself. I have to subtract 256. And that gives me 900. Got to take the square root of both sides. That becomes B. Square root of 900 is 30. So then I can find sine and cosine and tangent of everything. So if I'm looking at L, the opposite over hypotenuse. Opposite is 30. Hypotenuse is 34. Well, those are both even numbers. 2 will go into both of those. So 2 will go into 30 15 times. and it'll go into 34 17 times. Cosine of L would be 16 over 34. So that would be 8 over 17. And the tangent of L, opposite over adjacent, which then becomes 15 over 8. Then I can just flip that one for that tangent. I can put the sine of L over to cosine of M, and cosine of L over to sine of M. So that's how you do the 3 trig ratios or trig functions. There are actually 6 of them, but we're only going to do 3 of them. So this side of the worksheet is going to be for a quiz grade, but I'm going to show you how to do it. If I'm looking at number 1, this is a triangle I'm using, and these are my options right here. These are also my options of 2 and 3. So I'm not going to fill things in. I'm just going to write my answer next to number 1. So it says sine of A. Here's A. My opposite is 5. My hypotenuse is 12. So it's going to be my hypotenuse is 13. So it's going to be 5 over 13. So R goes there. Now I'm going to go down here to the bottom where I see a 1 right here, and R goes here. For 2 and 3, these are still my options. I'm going to write my answers next to them and then go fill it into the blanks. When I get down to 4, 5, and 6, these are my options. Same thing all the way through 24. You are going to answer this question here. So if it doesn't make words, it's probably wrong somewhere. So figure out where you went wrong. And you want to answer, what did Mrs. Margarine think about her sister's husband?